Alright everybody, your target for today is you want to be able to use the triangle congruence theorems that we talked about last time to prove that triangles are congruent. So you should have a proof packet in front of you. We're going to go through the first 4 proofs right here, and the rest of them will be on your own. The answers for those are on the remainder of the notes here today. So let's get rolling here. The first one we have is a figure, and we're given some information about that figure. That NK, this ray NK bisects the angle. A couple of segments are congruent, and we're going to kind of want to label those. I'm not going to label them on here, but labeling them on your figure there would be helpful. So we want to kind of focus on this figure. This is what we're looking at here, and we're given some information. The two triangles here that we're looking at is this triangle right here, JNK, and this other triangle, LNM, and all these triangles are going to be connected, so we gotta kind of do the best we can to separate those and tell the difference between them, even though they're touching each other. So the first thing I can say about this picture is just the information that's given. I know that this ray right here, NK, bisects JNM, so this angle here is cut in half by this ray. So I have an angle right here and an angle right here. And this is in between the two angles there. And I know that because it's given. I also know that NL, that's this segment right here from N to L, this is the same length as NJ, this right here. And also that NM, this angle, or this line segment right here, is the same as N to K. So this is where we kind of have a little bit of overlapping here, but if you can kind of separate those two, then it might be a little bit more obvious once we get to where we need to get to. So all that information is given to us, and the next thing I can say based on this, we have this angle bisector here, NK. This angle bisector, since this line or ray here, segment, separates or bisects this angle JNM, I can say that this angle right here and this angle right here are equal. So I can say that angle JNK, that's this angle right here, or this angle right here, is the same as this angle right here. Well, why can I say that? I can say that because of the definition of an angle bisector. I'm told, or we are told, that this line segment right here separates those two, so therefore these two things must be equal. So now we have enough information now to say that triangle JNK is congruent to triangle LNM because we have a side right here that is congruent to this side here, JN and LN, and then we have the known angle right here is congruent to this angle, and then this side length is congruent to this side length. So we can say that these two triangles are congruent because of the side angle side theorem, and that would be a little bit more clear if you have those things labeled. So we have this right here, there should be a tick mark here, an angle here, and then this side length, which is congruent to this side length, and they're both in the same positions there, so those two things are the same. Moving along, the next one here, we are given another figure where we have two triangles, and we're given that y is the midpoint of this segment WV. We have a couple angles that are the same. So we look at this figure here and the two triangles we're trying to kind of separate here, this triangle here, this triangle right here that are touching right at the point there, or at the vertex. First thing I'm going to say is all the information that's given. Y is the midpoint of WV, angle Z is congruent to angle X. And now based on this information that we're given, or just based on the figure in general, something else that I can say about this is that this angle right here and this angle here must be the same. WYX, it must be congruent to VYZ. This angle must be congruent to this. These two must be congruent. Why? Because they're vertical angles. These two must be the same. So now we have this angle's the same as this angle. We have angle Z is the same as angle X right here. And now we can say one more thing based on the fact that this is a midpoint. And since this is the midpoint of WV, we can say that WY is congruent to VY. So this side length right here is the same as this side length here. And now that we've established that two angles are the same, one of the side lengths are the same, depending upon the order of those now. And again, I'm saying that WY is congruent to VY because of the definition of a midpoint. I should probably clarify that there. Now that we have all that stuff, we can say what we were going back and saying before, that WXY must be the same as VZY because of the angle side theorem. We have a known angle here, angle Z, this angle here, and this side length. Angle, side, and it's the same on the other side. Angle, side right here. So those two triangles are the same because of the angle, side congruence theorem. Next one, we have a figure here given that BC is parallel to AD, so this line segment here is parallel to this line segment here, and BC is equal to AD. So this side is congruent to this side. So again, we have, here's our figures, and we're trying to prove that we have two kind of congruent triangles, this one down here and this one up here. So the first thing we're going to say again, information given. BC is parallel to AD, BC equals AD, and we would put some marks there, so BC is congruent to AD. Next thing I can say is that AC is congruent to AC. That seems almost a little redundant or obvious or unnecessary, but when we say this, what we are saying is that this side of the top triangle is the same side as the bottom triangle. We're just kind of establishing the fact that this is the same as itself, and there's a property for that. Why can we say that something is the same of itself? That is the reflexive property. To say that anything is the same as itself, the reflexive property says that that's true. So now we've established that we have this side is congruent to this side down here, and then this kind of diagonal is congruent to itself. Then we can say that angle BCA, that's this angle right here, is congruent to this angle, and this is going to go back to what we talked about last chapter, and we can say that because parallel lines imply that alternate interior angles of parallels are the same. So this angle must be the same as that angle. So alternate interior angles are the same. Therefore, this angle right here, DAC, must be the same as BCA. Now we have enough. We've established the fact that we have two sides that are the same, we have an angle that are the same. What are the positions of those? We have side, and then an angle, and then a known side. Down here, the side, and then the known angle in the middle, and then the known side. So we can now say that those two triangles, ABC and CDA, are the same because of the side angle side congruence theorem. And the last one for today, we're given a couple pieces of information. We have a couple triangles here, and we're given a bunch of angle measures that are the same. We have to prove that AB is equal to CB. So now notice we're not proving that triangles are the same, but we're going to go down that road anyway. AB is congruent to CB, so we want to prove that this is congruent to this. That BC right here is congruent to AB. And again, we look at the figures here and we see the two triangles that we're going to kind of base that on. This triangle right here and then this triangle down here. So the first thing I'm going to say is that information given, all those angles are the same. You can put the marks in there, so ADB. So this angle right here is congruent to CDB, which is this angle over here. And then angle ABD, which is this angle here, is congruent to CBD, which is this angle right here. I'm going to say BD is congruent to BD, and I can say that because of the reflexive property. Once again, this side BD right here is being shared by both of those triangles. So we're saying that this side in the top triangle is the same as this side in the bottom triangle, and we can say that because of the reflexive property. And now we kind of have enough information to go from here, because now we can say that the two triangles are the same. Why can we say the two triangles are the same? Because of the angle side angle property, angle side angle theorem, congruence theorem. Because we have a known angle right here, this angle and this angle, known side, and then known angles at the top. So these two triangles are congruent because of the angle side angle congruence theorem. So we've established those two things are the same, and since these two triangles are the same, every part of them must also be the same. So then we can say that AB is congruent to CB because of the corresponding parts of congruent figures. If these two triangles are congruent, every single part of them must be congruent also. And since BC looks like kind of like that hypotenuse there, this side BC must be the same as BA. So we'll be using these triangle congruence theorem proofs. Every single one of these will include angle side angle, side side side, angle angle side, or side angle side. So make sure you got those with you, And the rest of the solutions for this are on the remainder of the notes.